Okay, these are your notes for Unit 8, Stop 1, Pit Stop A. One-step equations, addition and subtractions. Okay? So if I open this up, what we're going to be doing today is we're going to be solving one-step equations using addition and subtraction. Well, in equations, we like to think of them as scales. Okay, they have to be balanced on both sides. So I've got a little scale here, and what we're going to do on these first two is we're going to draw a visual representation to help us keep our scales balanced. And then we'll go into, after I do the visual, then we'll go into actually we'll fill in these steps and then follow those steps to help us solve it algebraically. Okay, so what we're going to be doing is we're going to be figuring out the value of the variable. We're going to be solving for x, or figuring out what x is. So let's start with a visual. I like to call this monster math. So remember that this is a scale, and this is like the tipping point of our scale right here. All right, so whatever's on this side, in order to keep our scale balanced, it has to be the same on this side. Okay, so on this side of my equation, x plus 2 equals 5. I'll rewrite it up here. I've got an x, and I've got a positive 2. So I'm going to draw me two little monsters, and they're positive. So I've got two positive monsters. They kind of look like little Pac-Man guys, but that's just how I draw mine. Okay, so I have x plus 2 positive monsters. Well, on this side, I got 5 positive monsters. Okay, so I've got x and then 2 positives and 5 positives on this side because I've got an equals 5. So think of this line as like our equal sign. That's our tipping point of our scale. Whatever's on this side of my equation, because equations have equal signs, whatever's on this side of the equation has to balance to whatever's on this side of the equation. They have to be the same. All right, so what we're going to do is we're going to try and figure out what x is. We're going to solve for x. I don't want this variable here anymore. I want to assign it a number. So in order to do that, we are going to try and get this x by itself so that I can figure out what x is. All right, so that means in order to get the x by itself, or that's called isolating the variable. Okay, isolate means to get by itself. If you think of someone's in isolation, that means they are all by themselves. So if I'm going to isolate this x, or get it all by itself, I need to make these two monsters go away, because x is like, hey, leave me alone. I want to be by myself. So these monsters need to go away. Well, if you think back of when we were doing integers, okay, think all the way back to integers, we use what we called zero pairs, because if I have a zero pair, which is a positive and a negative, they cancel out. Zero pairs cancel out, because if that was like a positive 1 and a negative 1, if I add those together, okay, 1 plus negative 1, it equals 0. If something equals 0, then it doesn't exist anymore. It can go away. So let's make zero pairs for these. Well, if I have a positive and a positive, that means I need a negative monster, okay, for each of these positives to cancel them out. Well, remember, this is a scale, and in order to keep it balanced, what I do to one side, I also have to do to the other. So if I added 2 negative monsters over here, then I need to add 2 negative monsters on this side. That way my scale stays balanced. Well, now let's go through and let's cancel out our zero pairs, because if it's a zero pair, it equals 0, so it can go away. So on this side, this zero pair goes away, and on this side, this zero pair goes away. On this side, here's a zero pair, that can go away, and here's a zero pair, so that can go away. So on this side, I'm left with x, and on this side, I'm left with 3 positive monsters. So if these sides are equal, that means that x is going to equal 3 positive monsters, or positive 3. So x should equal positive 3. So that's a visual representation of how we solve a one-step equation. Now what I want to do is I want to go up here to the top and I want to write in our steps on how we're going to solve it algebraically so that we don't have to draw a picture every single time. So our first step is going to be to cut it in half. And when I say cut it in half, I mean to cut the equation in half. So if I had like x plus 1 equals 4, I would want to cut the equation in half straight down the equal sign to make sure that whatever I end up doing to this side, I'm also doing to the other side. So step 1 is going to be to cut it in half. So we want to see you draw that line through the equal sign. Okay, step 2 is going to be to isolate the variable. Isolate the variable, and that's an I, sorry. Isolate the variable. And remember, isolate means to get by itself. So we want to get the variable or the letter all by itself. And in order to do that, our third step is going to be to use the inverse. Remember, inverse means opposite. So the inverse operation. So the opposite operation. So the opposite of adding is subtracting. And the opposite of multiplying is dividing, or vice versa. The opposite of dividing is multiplying, opposite of subtracting is adding. So we're going to use the inverse or opposite operation to solve. Remember, what you do to one side, you must do to the other. Please do not forget to do this. We have to keep our equation balanced. That's why we drew that line, to help us remember what I do over here, I got to do over here too. So let's go back to number 1. And let's use these steps to solve this equation algebraically and see if it matches what we got up here. So step 1 is to cut it in half. So here's my equal sign. I'm going to cut it straight down the middle in half. Step 2 is to isolate the variable. So let's look here. What is our variable or letter? X. X is our variable. So I want to get X all by itself. So what is bugging X? Well, this plus 2 is bugging X. X is like, hey, plus 2, go away. I need to be by myself. All right? I need to isolate myself. So in order to do that, we're going to use the inverse or opposite operation. So the opposite of adding 2 is subtracting 2. And remember, what you do to one side, you also have to do to the other. So if I subtract 2 over here, I'm going to subtract 2 on this side. These two cancel because 2 minus 2 is 0, and 0 makes that go away. So those cancel, so I'm going to draw a line. All I'm left with now on this side is my x. Okay, my equal sign. And then 5 minus 2, well, that's 3. So I have x equals 3. Well, is that what I got up here? Sure is. Positive 1, 2, and 3. So x equals 3 would be my answer. Now, guys, there is no reason you should ever get any of these problems wrong, because you can always take what you get and plug it back in. So if I said x was 3, if I plug 3 back in instead of x, 3 plus 2 equals 5, it sure does. Okay, so again, you should never get any of these answers wrong, because you can always plug them back in and solve to make sure you did the right thing. So let's do one more example. This time with subtraction, of us drawing the picture, and then we'll just start doing it algebraically, all right, using our steps up here, because that's the way you're going to do it every time. But for you visual people, I want to draw you a picture. All right, so here is our scale. All right, here's our scale. What I have on this side, I need to balance it out with this side. So over here, I've got 4, so I've got positive 4 monsters. Okay, and on this side, I've got an x, and I've got negative 3 monsters. Okay, I've got 3 negative monsters. So I'm going to draw those in purple. Okay, minus 3 or negative 3. So I've got 3 negatives. Now, I need to isolate my variable or get the x by itself. So in order to do that, I need to cancel these out. I need to make these monsters go away. Well, we all know that in order to make a negative go away, we need to give it a positive or create a 0 pair. All right, so for this negative, I'm going to create a positive and a positive and a positive. Okay, and if I do that 3 times, if I add 3 positives over here, I'm going to add 3 positives over here because I got to keep my scale balanced. All right, now these are 0 pairs, so they can cancel out. They can cancel out. So these 0 pairs cancel. There's no 0 pairs on this side to cancel. So that means that all I have left on this side is x. And all I have left on this side is 1, 2, 3, 4, 5, 6, 7 positives. So I have 7 positives on this side. So I'm saying that x is going to equal positive 7. So let's use our steps up here and follow it on this part of the equation. We're going to do it algebraically and see if we get the same answer. All right, so step 1 is to cut it in half. So here's my equal sign. I'm going to cut my equation in half. Step 2 is to isolate the variable. So I want to get this x all by itself. Well, in order to do that, I need to make this minus 3 go away. And we all know that the opposite of subtracting 3 is adding 3. And what I do to one side, I also have to do to the other. Okay, 4 plus 3 is 7. And minus 3 and plus 3 equals 0, so those cancel. So all I have left on this side is x. So x equals 7 is what I got. That's what I got up here. So it looks like so far we did it right. Let's plug our answer back in. 4 equals, instead of x, I'm going to write 7 minus 3. 7 minus 3 is 4, and 4 equals 4, so I did it right. Okay, let's look at number 3. We're not going to draw any more pictures because it's kind of hard to draw decimals. So let's just follow our rules, our steps, and solve this algebraically. So step 1, cut it in half. Step 2, isolate the variable. So here's my variable, x. I want to get it all by itself. Well, I need to make this plus 4.2 go away. That's bugging the x, and I want to make that go away. So the opposite of adding 4.2 would be subtracting 4.2. What I do to one side, I'm also going to do to the other. These 4.2's cancel because 4.2 minus 4.2 is 0. So all I have left on this side is x. And then 7.3 minus 4.2, I'm going to do that over here just a little bigger. 3 minus 2 is 1. 7 minus 4 is 3. So 3.1. So I say that x equals 3.1. Well, let's plug it back in and make sure. So instead of x, I've got 3.1 plus 4.2 equals 7.3. When you add those together, you get 7.3, and that does equal 7.3. So yes, we did it right. Number 4. Step 1, cut it in half. Step 2, isolate the variable. Here's my variable or my letter. I'm going to get it by itself. So I need to make this minus 3 go away. So the opposite of subtracting 3 is adding 3. What I do to one side, I also have to do to the other. My 3's cancel. So I'm left with x on this side. And 2 plus 3 is 5. So I have x equals 5. Let's plug it back into our equation just to make sure. So instead of x, I'm going to write 5. Minus 3 should equal 2. 5 minus 3 is 2, and 2 does equal 2, so I did it right. Number 5. 4 equals x plus 1. Okay, step 1, cut it in half. Step 2, isolate the variable, so we're going to get x by itself. In order to do that, I'm going to do the inverse operation. So the opposite of adding 1 is subtracting 1. What I do to one side, I'm also going to do to the other. My 1's cancel. 4 minus 1 is 3, and all I have left on this side is x. So I have x equals 3. Let's plug that back in just to make sure. So 4 equals, instead of x, I'm going to write 3 plus 1. So 4 equals 4. Check, I did it right. Number 6. Step 1, cut it in half. Step 2, isolate the variable. So we need to get x by itself. To do that, I'm going to use the inverse operation. So the opposite of subtracting 10 is adding 10. What I do to one side, I will also do to the other. My 10s cancel. I'm left with x on this side, and 4 plus 10 is 14. Let's plug our answer back in to make sure we did it right. 14 minus 10 should equal 4. 14 minus 10 is 4, and 4 does equal 4. Number 7. So again, we have decimals. Doesn't change our steps. We follow the exact same steps, exact same rules. Step 1, cut it in half. Step 2, isolate the variable. So here's my variable, a. Remember, a variable can be any letter. It does not have to be x. It does not have to be y. It can be any letter. Okay? So here's my variable a. I want to isolate that and get it by itself. When in order to do that, I'm going to use the inverse or opposite operation. So the opposite of adding 6.5 is subtracting 6.5. What I do to one side, I'm also going to do to the other. Okay. 10.2 minus 6.5. Remember, when you're adding or subtracting decimals, you have to line them up. Can't do 2 minus 5, so I need to borrow, but I can't borrow from the 0. So I'm going to borrow from the 1. That becomes a 10. Now I can borrow from the 10. That becomes a 9. 12 minus 5 is 7. Bring down my decimal. 9 minus 6 is 3. Okay, so I've got 3.7 on this side. My 6.5's cancel. I'm left with a on this side. So I have a equals 3.7. So let's plug it back in and make sure it works. 10.2 equals 6.5 plus, and instead of a, I have 3.7. If I add 6.5 plus 3.7, 7 plus 5 is 12. 6 plus 3 is 9, plus 1 is 10. Bring down my decimal. 10.2. So 10.2 does equal 10.2, so we did that correct. Okay, number 8. This one has fractions. Still does not change our rules. We're going to follow the exact same steps. Okay, this time we're just dealing with fractions, so we're going to have to remember our fraction rules. Step 1, cut it in half. Step 2, isolate the variable. So here's my variable, y. In order to get y by itself, I need to make minus 1/5 go away. So the opposite or inverse operation of subtraction is addition. So instead of subtracting 1/5, I'm going to add 1/5. Okay? And what I do to one side, I'm also going to do to the other. My 1/5s cancel. I'm left with y on this side. Now I have 2/5 plus 1/5. Remember, when you are adding or subtracting fractions, you have to have a common denominator, or the denominator has to be the same. In this case, they are the same, so we don't need to find a common denominator. So we can just do 2/5 plus 1/5. Well, 2/5 plus 1/5 is 3/5. So y equals 3/5. Okay, we're going to go ahead and plug it back in. 3/5 minus 1/5 should equal 2/5. Again, we have a common denominator, so we can just subtract our numerators. 3 minus 1. 3/5 minus 1/5 is 2/5. And that does equal 2/5, so check we did that right. Last one. 1 equals w plus 1/4. Okay, so step 1, cut it in half. Step 2, isolate the variable. So here's my variable w. I want to get that all by itself or isolate it. In order to do that, I'm going to use the inverse operation. So the opposite of adding 1/4 would be subtracting 1/4. And what I do to one side, I'm also going to do to the other. All right, my 1/4 cancel. I'm left with W on this side. Now over here, I have 1 minus 1/4. I'm going to write that over here. Remember, like I said before, when we are adding or subtracting fractions, we have to have a common denominator. Well, this whole number 1 doesn't even have a denominator. So if I have the whole number 1, that is the same as 4/4. So 1 is the same as 4 out of 4. So I'm going to rewrite that, 4/4. So 4/4 minus 1/4, well, that leaves me with 3/4. So 3/4 equals W. Let's plug it back in to make sure. 1 equals 3/4 plus 1/4. Okay, plugging it back in. 3/4 plus 1/4 is 4/4. And we know 4/4 is the same as 1 whole, so yes, we did that right. Okay, these are solving one-step equations using multiplication and division. So in our last stop, or pit stop, excuse me, we did it with addition and subtraction. Now we're going to use multiplication and division. So this is chapter 8, stop 1, pit stop B. Okay, pit stop A was adding and subtracting. So this is pit stop B. Okay, notice that this page looks very, very similar to your last set of notes for addition and subtraction. That's because we follow the exact same rules. So let's revisit those rules. Step 1, cut it in half. So we cut our equation in half to make sure we keep it balanced. Step 2 is to isolate the variable. Okay, so we want to get the variable by itself or get the letter by itself. In order to do that, we use the inverse operation, okay, or opposite operation. And I will be making you use these vocab terms in class, so make sure you learn them. So use the inverse operation. Remember, what you do to one side, you must do to the other. Now, as you notice on 1, 2, and 3, there's pictures there for us to draw again if we would like to, but it gets kind of confusing when we're multiplying and dividing, so I'm not going to go through the drawing of the pictures. If you want to see this, then you can just ask your teacher and we'd be happy to show you. Okay, so number 1, 2 times x, remember a number next to a variable, that coefficient. Remember the number in front of the variable is called the coefficient. That means to multiply. So 2 times x equals -6. So 2 times some number equals -6. We're going to figure out what that number is. So step 1, cut it in half. Step 2, isolate the variable. So I'm going to get x by itself. I'm going to use the inverse or opposite operation. So this is 2 times x. Well, the opposite of multiplying by 2 is dividing by 2. And what I do to one side, I'm also going to do to the other. Okay, 2 divided by 2 is 1. And if you remember, when we were combining like terms, did we ever write 1x? No, we just wrote the number x. So that is an understood 1. So because we don't have to write that 1 there, these cancel. Okay, with addition and subtraction, we were trying to get it to 0. All right, with multiplication and division, we're trying to get to 1. Okay, so 2 divided by 2 cancels. I'm left with x on this side, and -6 divided by +2. Well, 6 divided by 2 is 3, and a negative divided by a positive is a negative. Got to go all the way back to those integer rules. Okay, so I say x equals -3. Well, let's plug it in just to make sure. 2 times -3 should equal -6. 2 times 3 is 6, and a positive times a negative is a negative. -6 does equal -6, so I did that right. So again, we're following the exact same steps, exact same rules, however you want to think of it to solve our problem. Number 2, 9 equals 3 times x. So 3 times some number is 9. And I bet you can look at that and figure it out, but we still need to show our work. So step 1, cut it in half. Step 2, isolate the variable. So we want to get x by itself. So I need to make this 3 go away because the 3 is bugging the x. So that says 3 times x. So I'm going to use the inverse operation. The opposite of multiplying by 3 is dividing by 3. What I do to one side, I'm also going to do to the other. My 3's cancel. 9 divided by 3 is 3, and all I have left on this side is x. So I say x equals 3. Well, let's plug it in and make sure. 9 equals 3 times 3. Well, 9 does equal 9, so yes, I did it right. Sorry. Number 3. Step 1, cut it in half. Step 2, isolate the variable. So this says x divided by 2 equals 8. Well, the opposite of dividing by 2, or the inverse operation, would be multiplying by 2. So I'm going to multiply by 2. And what I do to, well, I could write it up there. I could just write it down here. Sorry, multiply by 2. What I do to one side, I'm also going to do to the other. My 2's cancel because the opposite of dividing by 2 and multiplying by 2, that's 2 over 2, which equals 1. Okay. I don't know if you remember, that's called the reciprocal. Okay, so we multiply by the reciprocal. All right, so my 2's cancel. So I'm left with x on this side, and 8 times 2 is 16. So let's plug it back in. 16 divided by 2 should equal 8, and 8 does equal 8, so I did that right. Number 4. Step 1, cut it in half. Step 2, isolate the variable. So I'm going to use the inverse operation. The opposite of dividing by -2 would be multiplying by -2. I'll rewrite it down here, sorry, times -2. So I'm going to multiply by -2 on this side. My -2's cancel. And then -7 times -2. Well, 7 times 2 is 14. And a negative times a negative is a positive. So that's positive 14. I'm left with x on this side. Okay, so let's plug it in, make sure. -7 equals 14 divided by -2. 14 divided by 2 is 7, and a positive divided by a negative is a negative. So yes, I did that right. Number 5. 15 equals -3 times x. Well, step 1, cut it in half. Step 2, isolate the variable, so let's get x by itself. In order to do that, I'm going to use the inverse operation. So the opposite of multiplying by -3 is dividing by -3. Divide by -3, because what I do to one side, I have to do to the other. My -3's cancel. 15 divided by -3, well, 15 divided by 3 is 5. Positive divided by a negative is a negative. And then all I'm left with is x on this side. Let's plug it back in to make sure. 15 equals -3 times -5. -3 times -5, well, 3 times 5 is 15. And a negative times a negative is a positive. So yes, I did that right. Number 6. Okay, cut it in half. Isolate the variable. So let's do the inverse operation. The opposite of multiplying by -4 is dividing by -4. What I do to one side, I'm going to do to the other. My -4's cancel. I'm left with x. And 24 divided by -4. Well, 24 divided by 4 is 6. And a positive divided by a negative is a negative. Plug it back in. -4 times -6 should equal 24. 6 times 4 is 24, and a negative times a negative is a positive. So 24 does equal 24, so we did that right. Number 7. 4.2 equals 2.1 times a. Cut it in half. Isolate the variable, so we need to get a by itself. I'm going to use the inverse operation, so the opposite of multiplying by 2.1 is dividing by 2.1. What I do to one side, I'm going to do to the other. My 2.1's cancel. So I have a on this side, and I have 4.2 divided by 2.1. So top in, bottom out. Top in, bottom out, typo. I cannot have a decimal outside my house, so I'm going to move it one time to make that a whole number. And what I do outside, I'm also going to do inside, kind of like what we're doing over here. So I move that and take my decimal straight up. 21 will go into 42, 2 times exactly. So a should equal 2. Plug it back in just to make sure. 4.2 should equal 2.1 times 2. 2.1 times 2. 2 times 1 is 2. 2 times 2 is 4. I have one number behind a decimal, so one time. So 4.2 does equal 4.2, so I did that correctly. Number 8. This one has a fraction, so we're going to have to bring back our multiplying and dividing fraction rules. Remember those. So step 1, cut it in half. Step 2, isolate the variable. So the opposite of multiplying by 1/3 is dividing by 1/3. What I do to one side, I'm going to do to the other. My 1/3s cancel. I'm left with y over here. Now I need to divide fractions. Okay, 9 divided by 1/3. I'm dividing fractions, so I'm going to put a 1 under my 9. And remember, when you're dividing fractions, it's keep, change, flip. So I'm going to keep, change, and flip, or write the reciprocal. So instead of 1 over 3, it becomes 3 over 1. Then I can multiply top times top, bottom times bottom. 9 times 3 is 27. 1 times 1 is 1. And 27 over 1 is the same as the whole number 27. So y should equal 27. Okay, we can plug that back in and see if we did it right. 1/3 times y, or times 27. Put a 1 under it. Should equal 9. Top times top, bottom times bottom. 1 times 27 is 27. 3 times 1 is 3. And 27 divided by 3 is 9. And 9 does equal 9, so we did do that correctly. Number 9, last one. 6 equals x divided by 5.3. Step 1, cut it in half. Step 2, isolate your variable. So let's get x by itself by using the inverse operation. The opposite of dividing by 5.3 is multiplying by 5.3. What I do to one side, I'm also going to do to the other. My 5.3's cancel. So I have 6 times 5.3. Remember, when you're multiplying decimals, you do not have to line them up. So 6 times 3 is 18. 6 times 5 is 30, plus 1 is 31. I have one number behind the decimal. So I have 31.8 should equal, and all I have left on this side is x. So x is 31.8. Well, let's plug it back in to make sure. So 6 should equal 31.8 divided by 5.3. Top in, bottom out. Can't have a decimal outside my house, so I'm going to move it once. What I do outside, I must also do inside. Let's take it straight up so I don't forget about it. So 53 won't go into 3. It won't go into 31, but it will go into 318. We got to figure out how many times. Well, we're hoping it's going to be 6, so let's see. 53 times 6 is 318. So 6 does equal 6. We did